Let me start off by saying two things. First of all, I should have made this model a few days ago. It's been some controversy around it, so yeah. Second, metric for the win. All these feet and miles and stuff. Get a grip, United States. You're only one of 3 countries left doing this cryptic stuff. So we have the Maine Surveyor here, who's made these observations at the Halfway Rock Lighthouse and Seguin Island Lighthouse. And even though his eye level is lower than both of the lighthouses, they again are both below his eye level here. And Seguin Island is just about halfway up the Halfway Rock Lighthouse. This is not what you should see if the Earth was flat. Let me show you why. So here we have the 3 different versions. Flat, obviously. A radius of 6,371 kilometers metric. And this one, 7,500 standard diffraction, thanks to Walter Bislin. So, which one should we start with today? Let's go flat. We have observation height here, and the distances and the height of the objects. So if we zoom in a bit here. Here we go. And this doesn't make any sense because now Halfway Rock is halfway up the Seguin Island. It was just the opposite. Seguin Island was halfway up the Halfway Rock. Yeah, this doesn't make sense. Let's check the globe model. And yes, this is zoom compression. We don't live on a basketball. This here is 69 miles or 111 kilometers. That's 1 degree of the Earth's curvature. That's 2 degrees of the Earth's curvature. So zoom compression is a thing. Let's check here. Now this is more like it. Now the Seguin Island is halfway up the Halfway Rock. So this looks a lot more like what the Maine Surveyor had in his scope. Let's try some refraction. Now this is not that long of a distance, so refraction doesn't make that much change. But you can still see here that Seguin Island is halfway up the Halfway Rock. So yeah, what matches best? And if we are not allowed to use refraction, flat earthers, just what do you need for this to match this? Because again, Seguin Island is halfway up Halfway Rock, not the other way around. Call it what you want. Perspective, yeah, whatever, I don't care. This doesn't make any sense. Let me also address this stupid idiotic claim from Try Thinking about the double crosshairs or double horizons or whatever. Is it just a matter of calibration? A tiny calibration error. Let me take you back to this SketchUp here, where you have the T2 and the auto level. The T2 is here. It's not the exact one, but that's what I found in SketchUp. And the auto level is there. So we can assume that the auto level is level. That one is okay. And the T2 needs calibration because the mechanics in here are highly fine-tuned and needs calibration. So when you use those instruments normally, they are used at about 100 feet, 30 meters down here. So you point at that cross in the middle, but the T2 has a slight error here, just a couple of millimeters, a fraction of an inch or something. That's the error in calibration. What happens next when you use that instrument at further or longer distances over here? That error will be bigger. That's pure simple geometry. If you don't understand that, please go back to school. This is as simple as it gets, really. So now the auto level still hits the center, but the T2 misses by 35.4 millimeters or something. This is just an example, nothing more than an example. And because of that, at that distance, the same 35.4 millimeters here, if you see here, these switch back and forth. Now the lighthouse is at the same place, but the crosshairs is at different places. This is not magic. This is just how it is with calibration of the instruments. Why you even find this so difficult or hard to believe, I have no idea. Thank you so much for watching, everybody. See you next time. Bye-bye.